Hey everyone, welcome to week 2 of data visualization. So last week we learned about how to iteratively plot using ggplot, and we also learned just about kind of the function of ggplot. So this week we're going to build off of that and actually learn how to visualize your data given some of the best practices that we've learned, as well as how to customize your color and how to show your data in non-visual ways to make it more accessible. So on our website, there's a lot of awesome resources that I definitely suggest that you all check out. There's also a lot of good resources online. So, always feel free to Google any questions you have. There's also this thing called the R-Graph Gallery that has a lot of, inspiration for trying to figure out how to best plot your data and depending on the type of data you have. So generally, when we're thinking about data visualization, we really want to keep it simple. Less is more in this case. And so that means removing redundant labels, removing colors that aren't signifying something important about your data. This means, keeping your text clear and concise. And so definitely think about this, as you're creating your plot. And also, I want to point out that there's maybe two ways of thinking about how to spend your time with these plots. Like, are these plots more for you and your own data exploration? If so, maybe you don't need to spend so much time, messing around with the more aesthetic parts of your plot. Whereas if this plot is for communication, like if you're going to show this at a conference or in a paper, it's really important to spend time on how you are visualizing this final plot to make sure that it's accessible to a wide range of people, especially, people that are colorblind, or if someone is unable to see your plot, we're going to show some alternative ways for you to share your data. And then also, if I think it's important to show that you've put a little bit of effort into creating a plot that is nice to look at, because I think it makes others also want to understand your work a little bit more. So just thinking about like science communication when making that final plot visualization is really important. Okay, so enough talking, let's get to coding. So we're first going to load in the tidyverse package. And let's also load, oops, forgot to run that. GG themes, because we will use this potentially. And also, we loaded in the surveys data on the video last week, and we're going to continue working with that. And I also have removed NAs from the weight and the hind foot length columns, just to make it a little bit easier for data visualization. And I also want to jog everyone's memory about the ggplot template generally. So ggplot, you specify your data here, and then you also are going to specify your aesthetics that you're mapping onto your plot. So this is your X, your Y, if you have any sort of grouping variable. And then you have a geom function, which is telling ggplot, if you want a scatter plot, a bar plot, a line, many others. And so given this, let's bring in one of the plots that you made last week, which followed this code. So ggplot data equals surveys. And I'm realizing now I did not run my surveys data. So let's bring that in. And then we had aesthetics. I think for X, we had weight. Y, we had hind foot length. And then we did a scatter plot. So geom point So let's run this and it should look familiar to you. And so, okay, this is our basic plot. We see it's in black and white. We haven't really specified anything regarding the color here, so that's why it comes out as this. Let's actually create one where we do specify a grouping by species ID though. So we have our plot here, and I just copy and pasted. I'm going to add a third specification in the aesthetics parentheses and just say color by species ID. And we'll run this. And now we see that there is a different color for each type of species ID. Okay. So, this is one way. This is just ggplot providing kind of its basic standard coloring. But what if we want to make this color more accessible to those who have color blindness? So I'm going to show you one way to do that. So I just copy and pasted the same, or sorry, I copy and pasted code from my other notes, but here I've added to the geom point scale color colorblind. And when we run this, let's see how it changes. So it is a different color scheme, and this is more accessible. So another way of doing this is actually using this function called Viridis. And this is a function that changes the color scheme so that basically how it represents the differences in data would still be captured if it were to be changed to black and white, which is important because a lot of times when you publish in a paper, they won't it won't necessarily be able to be published in color. And so being able to convert it to black and white is important to still showing what you're trying to get across with your data. And then also it pops the colors a little bit more, so it is easier for those with color blindness as well. And so there are, two main functions I typically use within Viridis. One is for discrete data. And so let's copy this plot we made. And instead of scale color colorblind, we're going to write scale color Viridis. And there's a bunch of options that pop up. And I'm actually going to choose this one that is _D, and that represents discrete. And I chose discrete because we have these discrete groups for species ID. And so you can see the result here. There's also an option to change the color scheme. So we'll do option B. And you can see it's a slightly different color scheme there, going from black to yellow. And then there's also an option for continuous data. So let's try this out. So I just copy and pasted, and instead of species ID, let's do weight, which we know is a continuous variable. And we're just going to change the D to a C. Hit run. And now you can see we have a spectrum from black to yellow here. So in general, best practices with data visualization, there are many, but keep in mind that we want to keep it simple and we want to make it accessible. And those are the big takeaways from this section. I also want to spend a couple minutes just talking about how to present your data in a non-visual way. So let's install a package called Braille R. Oops. And I already have mine loaded, so I'm not going to install, but I will bring it up here. And one thing I wanted to point out here is this is a new package for many of us, and we might not know all the functions it provides. So you can do this thing where you pull up the pack, or you write the package name and then you go : : and it will show you all the functions in this package. And this is really handy for any package when you're trying to explore what the functions are. And another benefit of this is you're sort of hardwiring it into your code. So by typing this out and doing the colons, it actually tells R, hey, look into this package for this function, which the function we're going to use is VI. And I'm realizing now that I have actually not saved a plot to put into here. So I'm just going to go back up to the continuous data plot and name this bar, not bar plot, but I'll just name it plot. And then put plot into here. And it should, interesting. Okay, that did not work out great. I wonder why. There's no specific method written for this type of object. Huh. Okay. Well, normally it would just pop out a text. So let's see. Run that again. Okay. I must have just hit something weird there, but this is what I was expecting to get. So you run this function and it will give you a textual output for your plot. And this is something that you could use in, say, a journal article. Instead of putting, or in addition to putting your plot, you can have this textual representation. And this, I just want to point out, says it's an untitled chart with no subtitle or caption. So it would be good, you know, if I actually was going to publish this, to make sure the labels were descriptive and useful. Okay, so one other thing I wanted to show is how to create a noise to represent your plot of your plots. Okay, so there is another package called Sonify, and I have this in my library already, so we'll call it up. And essentially, Sonify reads your data from left to right along your x-axis, and the length of time represents the amount of data, and then the pitch of the noise represents the value of your data. So lower value, lower pitch. So let's play around with that. Say I want to look at specifically hind foot length. My computer is now running a sound to represent this data. You can't hear it, I don't think, over Zoom. Maybe you can, but play it on your own computer and check it out. So that is all I wanted to go over for today. Thanks for sticking with me, and see you in class on Thursday.